So 30-1, trigonometric functions part 2. So these are all your formulas. You have your reciprocal identity, which you can't flip your angles. You have to flip your answer. Why are you laughing? Okay. You have cosecant equals 1 over sine x, and secant equals 1 over cos x, and cotan equals 1 over tan x. Do not flip your angles. And then tan x equals sine x over cos x, and cotan equals cos x over sine x. Your Pythagorean Theorem identities is when you have squareds. Can you use squareds when you have singles? Like 1 plus tan x? Can you say 1 plus tan x equals secant x? No, it's 1 plus tan squared x. So you can't do that. Sum and difference identities. You have sine a plus b, cos a plus b, sine a minus b, cos a minus b, and then the tans. And what do you have to use those for? Angles that are in the unit circle, but they ask you for exact values. So like sine 75, right? Or cos 75, or sine 15, or tan 15. Any of those that you could do like 60 minus 45, or 45 minus 30, right? And you could get 15. So they ask you for exact values that aren't directly on the unit circle, but their angles added or subtracted are on the unit circle, you would use those. Okay? Or if they just give you this, you can't distribute it in. You can't go cos A plus cos B. All right? So solve algebraically and graphically. This is the actual curriculum outcome. Solve algebraically and graphically first and second degree trigonometric equations with the domain expressed in degrees and radians. Determine using technology the approximate solution of a trigonometric equation in a restricted domain. So we're going to do this algebraically, and then we're going to check it graphically, right? Because they could just give it to you like this, and you could 100% just put in your calculator. Now this one we can't factor instantly. Why? You have a cos squared x and you have a sine x, which you can't factor because they're not the same. So we can change the squared. We can change the cos squared to 1 minus sine squared. So we're going to get 2 bracket 1 minus sine squared x plus sine x minus 1 equals 0. That would get us 2 minus 2 sine squared x plus sine x minus 1 equals 0. And then I'm going to move it all to this side. Why am I going to do that? Yes, you have a negative from the 2 sine squared x, and I want it to be positive. So I'm going to get 2 sine squared x minus sine x. And then 2 and negative 1 together is positive 1. But when I move it to the other side, it's going to be minus 1. And then what could I do here to make it easier? Do decomp, and you could replace the signs with m as long as you remember to put it back. So m equals sine x. You do 2m squared minus m minus 1 equals 0. What could you do? What times what gets you negative 2? What plus what gets you negative 1? Negative 2 and 1. 2m squared, and then you replace this with it, right? Negative 2m plus 1m, because negative 2m plus 1m is negative m, and that's why the first and the last stay there, because you're just replacing the middle. So you can get 4 terms in group. Take out a 2m, and you're left with m minus 1. Then this is actually that, so I just take out a plus 1, and I'm left with m minus 1. Take a GCF of m minus 1 out, and then I'm left with 2m plus 1. Solve them out, and I'm left with m minus 1 equals 0, 2m plus 1 equals 0, m equals 1, 2m equals negative 1, m equals negative a half, and then people would stop here. But the question never had an m in it, not one m. So you have to put the sign, which looks like a y, sine x back in. So now we have sine x equals 1 and sine x equals negative a half. So we're trying to find x, what x equals. X is in the spot of the degree or the radian, right? So our answers are going to be x equals some sort of degree or some sort of radian. How do we know if it's degrees or radians? The question will say. It says negative pi to pi inclusive, correct? So it's radians. So if it's from negative pi to pi, I still find all my answers from 0 to 2 pi, and then just check the coterminals. Okay? So sine x equals 1. Where does x equal 1? Sine x equal 1, sorry. When y equals 1, where's y equal to 1? So 90 degrees. Yay, I'm done. No, it's pi over 2. Now, if I check the coterminals, it's going to end up being outside, right? I'm going to get negative 270, which is outside of negative 180, which is pi. And if I check the other way, I'm going to be way out, because it goes from negative pi to pi. Then sine x equals negative a half. Sine is negative a half here and here at the 30 degrees. So I'd have 30 and I have 210. I'm just showing it in degrees because most of you are going to do it in degrees and convert after, even though I tell you not to, you will, which is okay, as long as you get the answer right. So the coterminal to 210, 210's outside the domain, right? The domain's from negative 180 to 180, 210's outside. If I subtract 360 from it, I'm actually going to get negative 150, and that's inside the domain, yes? So if I subtract 360 from 30, we get negative 330 or positive 390, which are both outside the domain. We agree? So our two answers that are inside the domain is negative 150 and 30, which is actually x equals pi over 6 and negative 5 pi over 6. So the answer to this is x equals negative 5 pi over 6, pi over 6, and pi over 2. Get out your calculators. How can we check it in our calculator? We have an equation. It has one variable. It has an equal sign. What can we do every single time? y1, y2. And change your domain. Whoa, negative a half. Whoa, this is so wrong. Why didn't you guys stop me? I was afraid. I was very afraid. La. No, it's terrible is what it is. This one is 330. That's sine positive a half, silly me. Which, if I subtract, it's negative. So close, but so wrong. Okay, negative pi over 6. Let me see. Negative pi over 6. There. That's much better. Where would I catch it? Where would I catch that oops? If you went and used your calculator, right? Because once you punch into your calculator, you're going to get 3 answers. Where are you going to restrict your domain? That's the key thing. You're going to punch into y1, y2, which is great, but you need to make sure that your window is set to the restricted domain, right? So that you don't get extra answers outside of it. Now, all those answers are going to be decimals, but you could turn these into decimals and match them. We agree? Okay. So, if you wanted exact values, could you not keep the domain in degrees and then get your answers in degrees and convert those to radians and have exact values? Yes. If you go directly to radians, if your window's in radians, it's going to give you decimals. Okay? So if you want to have exact values, you could keep it in degrees and then convert to radians. So everyone's y1, y2ing? So type this into y1 and type this into y2. How can you type cos squared x into your calculator? Cos x in brackets squared. Okay, type it in. Okay, so we're going to go to cos x squared. Was it plus sine x? Plus sine x minus 1. If you don't close the brackets, you're not going to get the actual question. And 0. Now remember, if you don't have colors, you could go over here and hit enter and it'll make it thicker, right? It can make your second line thicker. I'm going to go to my window and just make it in degree. The only reason why I'm doing that is because then I can just divide by 180 and make it exact values. However, if they ask for your answer in radians in decimal form, would we change this to degrees and then change it to radians and then write down the decimals? No, that would be long. It would be ridiculous to do that. You would just keep it in radians and then write down the decimals. right? Be way easier. Now remember, whatever you make your domain be, I push the button cos and I push the button sine, right? The moment I press those buttons or second of those buttons, I have to think what mode do I need to be in, okay? And I'm going to make my x-axis in degrees. If you make it in radians, that's fine. Put it in radians, right? If you get something that's like crazy and it doesn't look anything like it, or it looks like someone's having like a heart attack, you're in the wrong mode, okay? Think about that. So we're going to go to window, and we're going to go negative 180 and 180. And I'm going to make it go up by 45. So second trace 5. I'm going to get onto the straight line. Enter, enter, enter. Negative 150, which is negative 5 pi over 6. Second trace 5. Enter, enter, enter. Negative pi over 6. Second trace 5. $90 pi over 2. So you have all of them. And I made my domain be restricted to the domain that it is, so I know any answer in there is golden. Okay? All right. So this one, determine using technology the general solution of a given trig equation. General solution means you need that like plus 180n NEI or plus pi n NEI. You need the general solution, the solution for every single answer because they didn't restrict your domain. Okay? So find the general solution, express the solution in degrees. So hint, use your graphing calculator. We'll check with our graphing calculator, but we're also going to solve it algebraically. So sine 2 theta is a formula off your formula sheet. It's 2 sine theta cos theta minus cos theta equals 0. What can I do? This is where people are stuck. If it's like the worst econ, you guys can do it. But if I give you this, you're like, eh. Yeah, take out a cos. Cos theta equals 2 sine theta minus 1. And then we just solve for them, right? So we get cos theta equals 0 and 2 sine theta minus 1 equals 0. So sine theta would equal what? 1/2. So we're going to find the answers to those and then state the general solution to each of them, right? So cos theta equals 0. Calgary Stampede. So it's when x equals 0. When does x equal 0? On the y-axis, because x equals 0 is the y-axis, right? So what's our first positive answer? And we have to do this in degrees. What's our first positive? 90. And then our next answer is 270. We agree? So what would our general solution be? Because we can actually put these two together. Theta equals 90 degrees plus n NEI. You want it to be integers, because if it's reals, then you have decimals in there, and we don't want those. That would not be helpful. Yep. The real number system includes irrationals and rationals and everything. Yep. And then we have sine theta equals 1/2. Sine theta equals 1/2 here and here. All right. This one is what? Degrees? 30. And this one is 150. And the error lies in the fact that you try and put them together. You literally can't, like, you can't go 30 plus 120 and NEI. Then you would be getting every 120 along the way. Do we want every 120 along the way? No. Unless they're straight in line with each other, you're going to get two general solutions for that. So we're going to get theta equals 30 degrees plus 360n. And then it'll land back on it, NEI. and then 150 degrees plus 360 degrees N NEI. So that's general solution. So far we've solved a second degree where we actually have to substitute in. That's the hardest solving I can give you, right? Where you actually have to substitute in before you can even solve it. Then we did this one where you have to state general solutions. And the GCF is the one that people forget about. They'll sit for life and be like, I have no idea how to do this. Worst case scenario, if you are stuck, type it in your calculator. It might help. Worst case, it doesn't. You're back to where you were. Like, meh, try it out. The next thing is identifying correct errors in the solution for a trigonometric equation. Okay. This is also where they're substituting in. If they substitute in a value, when do they substitute the value in for theta if they're verifying? Immediately, right at the beginning. You don't you don't proof it, and then at the end, left hand equals right hand and put in pi over 3. That's not how you do it. A lot of you try and do it that way. It's not correct. That is a proof, and then you're just putting some value in at the end and ruining the proof. You're taking this pretty proof and ruining the proof by putting a value in at the end. If you're trying to prove that pi over 3 works, you plug it in right off the bat and get numbers right away in your next step. Okay? So, student A substituted theta equals pi over 3 into both sides of this identity, sine squared theta minus 1 over cos. So there's 3 students did this way. Into both sides of the equation and got left side equals right side. Student B entered left side into y1 and right side into y2 and concluded the graphs are exactly the same. Explain why these methods are not considered a proof. This one you used one value and proved it worked for one value. Yay. Right? So student A didn't prove it. It verified. Oops, verified. One value worked. And if they tell you to verify, you're done. Yay. But why did student B not prove it by showing a graph? What do you mean by that? Right, there's numbers on the graph. They basically used values too, but the only values they used were what? Whatever the window was. Is the window infinite? No. Could the graph maybe later not be the same as the other one? Like further down the graph, but you just can't see it? Yeah, so you're still only verifying, you're verifying for more quantities of x now, but still not infinite numbers of x, right? So student B verified all the x's in the window. But still not infinite number of x, right? Student C correctly completed an algebraic process to show left side equals right side. So you guys show the proof. Go, try it out. And then state the non-permissible values. This is where people fall apart. We're gonna try, okay? So we have sine squared theta minus 1 over cos theta. If they give you one of these, you should be the happiest camper on the planet. Sine squared theta minus 1 is just the formula rearranged. Negative cos squared theta. So you're going to get negative cos squared theta over cos theta equals negative cos theta. The squared and the cos cancel. And we get cos theta, negative cos theta, equals negative cos theta. Left side equals right side. If we wanted to verify this for pi over 3, like they said, pi over 3 would go sine squared pi over 3 minus 1 over cos pi over 3 equals negative cos pi over 3. You fill it in instantly. Not even after the first step when you've canceled. You're not canceling anything off. You fill the pi over 3 in immediately. Okay? What non-permissible values? What's the only thing in the domain? Just cos. So we're going to state where cos theta can't equal 0. Where does cos theta equal 0? When x equals 0, which is 90 and 270. So it's just x. Didn't say anything about degrees or radians. It's in radians. So x cannot, not x. There is no x in this question. Theta cannot equal, not, there's no degrees in this question. pi over 2 plus pi n nei. Okay. So prove trigonometric identities using reciprocal identities, quotient identities, Pythagorean identities, sum and difference identities, double angle identities. Explain the difference between a trigonometric identity and a trig equation. An identity proves that what? It works for everything. What is a trig equation? What do I ask you to do when I give you a trig equation? No. No. Kind of, but no. What am I asking you to do? When I give you a trig equation, what's the word? No, that's a proof. That's an identity. No. I'm asking you to stop. I'm asking you to do what? No. What? Solve. So when it's a trig equation, you're asking them to solve. So you're asking them to solve for one value, not proof it or verify it or anything. That's an identity. That's the difference. It's the other one. A trig equation you're asking to solve. What is solving actually asking you to do? Find the x-intercept. What's another word for x-intercept? Zeros and roots. Okay. So this one, verify that sine theta or sine x cos x equals tan x minus a half for the value x equals pi over 4. Go, verify it. So we're going to plug in pi over 4. We're going to substitute it in. Sine of pi over 4, cos of pi over 4, tan of pi over 4. Why is pi over 4 nicer? Because the x and y are the same and tan at that value is 1. So we're going to get root 2 over 2 times root 2 over 2 equals root 2 over 2 divided by root 2 over 2, which is 1 minus a half. Root 2 times root 2 is 2 over 4 equals 2 over 2 minus a half. So you get common denominator. 1 half equals 1 half. Left side equals right side. So we verified for one value it works. Determine graphically the potential validity of a trigonometric identity using technology. So graphically determine if this is a potential identity. So type it into y1, y2, and then we're going to actually solve it after. Remember, if you don't remember how to type them in your calculator, your formula sheet tells you how to type anything that's not sine and cos and tan into your calculator, right? So it'll tell you secant is 1 divided by cos. So if you don't know how to type it in, it will tell you. So there's the equation up there. So we're going to get y1 to be 1 divided by cos x times tan x. The second one, yeah. Cos. I'm going to put in brackets so that the numerator's in brackets too. Cos x squared minus 1 close bracket, because my numerator needs to be in a bracket, divided by open bracket sine x. So when you have more than one term, you should be typing it into your calculator in brackets. If you're not typing it into your calculator, that's weird, because this is your practice for the diploma. I'm really good at these. What? Yeah, because then you're not actually typing in the original question. You're supposed to verify the original. If you were stuck, 100% go that route. Something is shady. What is shady with mine? Oh, maybe I need to have this in there. Yours doing that? It looks exactly like that. So are they the same? Like they're drawn on top of each other? Yeah. So are they the exact same graph? Huh. The x-intercepts are lovely. They are the same. Yes. Are the graphs exactly the same? No. So are these the same? No. No, that they're not. But if I checked what value? 0 in for x, what would happen? It would work. And then if I check the other ones that are on there, like 180 and negative 180, it would work. But does it work for all values? No, that would be bad. So, graphically determinative is a potentially an identity. Is it potentially an identity? Potentially, it would show that if you picked 0 or 180 or negative 180, that would work, right? And you'd say it works for that value. But isn't it an identity? No, because it's not the same on both, right? We agree? All right. Determine the non-permissible values of this identity. So, what do we have to do? We always have to turn everything to sines and coses if possible so that we can find out if we have anything in the denominator, correct? So here we have sine x plus tan x, which is what? What's tan x? Over 1 plus cos x equals sine, or 2 sine x cos x, nothing in the denominator, over 2 cos squared x. So technically, what do we have? Where are our errors going to be? Where are NPVs going to lie? 1 plus cos x is going to cause us issues. That cannot equal 0. 2 cos squared x cannot equal 0. And what else? Cos x. So for this one, we're going to have cos x cannot equal negative 1. Where does cos or x equal negative 1? At 180 or that's not tricky. That is pi, yeah. But when does the next one happen? So you were right. Stop guessing. 180 plus 360 and NEI. Or if it was radians, it would be pi plus 2 pi n NEI. Because you'd have to go a full 360 to get back there, right? Either way, even negative, do the same thing. 2 cos squared x sounds a lot worse than it is. Divide by 2. All right. Cos squared x cannot equal 0. And then when you square root of 0, what happens? No, it's not bad. When you square root of 0, what do you get? 0. Plus or minus 0, but there is no signs on 0, so it's 0. Remember that when you square root anything, you get positive or negative, right? So when I gave you 4 sine squared x equals 1, you move the 1 over and you divide by 4 and you'd square root it to get the cos of the sine squared by itself. You get positive or negative, so you'd actually get 4 answers. You get them in every single quadrant. Remember when we did those ones? 4 sine squared x minus 1 equals 0. You'd get 1 over 4. You'd square root that. You'd get 1 over 2, plus or minus. So you'd get in every quadrant. So remember when you square root, you have to remember the plus or minus signs, or else you're going to only get 2 answers instead of 4. And that answer will be there, and it will be wrong. And you will be happy, and you will move on, and I will be sad. That would be how it will work. So cos x equals 0 here and here. this is cos x equals 0, too. These are actually the same NPVs, so we don't have to deal with that one. So it's going to be at x equals, or cannot equal, 90 plus 270n, or plus 180, sorry. Or x cannot equal pi over 2 plus pi n NEI. Okay. Here's 2 proofs, go. So remember, when we have division in between these, we have to actually get full fractions before we can flip, right? A bunch of people will try and flip the 1 over cos. You can't flip it until it's a full fraction, right? Both sides of the division sign have to be in a full fraction form. You have to make complete fractions before you can flip. This one I can put together because they both have a sin x in the bottom. This one I have to make a common denominator first. So I'm going to multiply this by cos x over cos x. So I'm going to get division of 1 plus cos x over cos x. And then we're going to get cos x plus 1 over sin x times cos x over 1 plus cos x. And then now our 1 plus cos x can cancel, and we're left with cos x over sin x. But they want a single trig. So what would it be? Cotan x. The next one, 1 plus tan x and 1 plus cotan x are not squared, right? So we cannot use the Pythagorean Theorem identities that you try and use all the time. You can't. You literally just have to turn into coses and sines. So we're going to get 1 plus sin x over cos x divided by 1 plus cos x over sin x. Looks super confusing if I stack them, doesn't it? It's a lot easier if you write them side by side. So tan x is sin x over cos x. So I'm going to write this as 1 plus sin x over cos x divided by 1 plus cos x over sin x. I cannot flip anything because I have partial fractions on both sides of this division symbol. And until they're a full fraction, I can't do anything with them. So, common denominator, multiply by cos x over cos x, multiply by sin x over sin x. So I'm going to get cos x plus sin x divided by cos x divided by sin x plus cos x divided by sin x. Remember, you have to carry the left side down and the right side down. Flip, so I'm going to get cos x plus sin x over cos x times sin x over sin x plus cos x equals sin x over cos x. These are the same, they cancel. So I'm going to get sin x over cos x equals sin x over cos x. Left side equals right side. The next one, sin 2x should be a red flag. What could you have to change that, right? What could you change it to? 2 sin x cos x. Equals 2 sin x over cos x divided by, what's 1 plus tan squared? The same as secant squared. So we get 2 sin x cos x equals 2 sin x over cos x divided by 1 over cos squared x. Two sine x cos x. And flip it. The cos and the squared cancel. And left with 2 sine x cos x equals 2 sine x cos x. Left side equals right side. An aside and not part of this question, if I give you this, 2 cos squared x equals cos x, and I asked you to solve it, a totally different side question. What can you not do? Yeah, that, but I meant something that would be like legit. What can you not do? I don't know why you would do that. You would want to do that. Yeah. What would you not want to do? No. You would not want to divide. Some people do this. And then it's equal to 1 and they solve. You can't do that. You're getting rid of the cos over here and you're saying it's a 1, but you got rid of the answers to cos as well. You can never, when solving, you can never divide a sine x over or cos x over, and you're like, I'll never do that. People do it all the time. Or they'll say, where's the error? And they give you steps and they divide it over, and maybe you've never thought about it, but when you see it, you're like, ooh, that's really smart. No, it's not. You can't do it. That's the error. Okay, don't be like, oh, that student's a genius. I've never thought to do that before. You shouldn't have, because it's wrong. Okay? If you have this, you're going to move it over. You're going to go 2 cos squared x minus cos x equals 0, because when you have a squared, you bring everything to one side, right? And then you take out a cos x, and you'd have to solve out where cos x equals 0. We agree? But if you divide that cos x over, that's gone. You're missing half your answers, which is, oh no, is real. It's reals. Okay, how would you catch it? You would type it into your calculator, do your domain, and you'd be missing answers, correct? Which is a hint that something is wrong. Okay. Secant squared x minus tan squared x equals 2 sine squared x plus 2 cos squared x, which equals a half. I see secant and squared x and tan squared x by each other, and I know that they can cancel each other out because they're Pythagorean Theorem identities. So secant squared x on there is 1 plus tan squared x, is it not? So I'm going to replace secant squared x with 1 plus tan squared x. And then subtract tan squared x because it's still there. So I just replaced this. What can I do to the denominator? I see sine squared x plus cos squared x. I just see issues in front of it. If you take out the 2, you're left with sine squared x plus cos squared x. And sine squared x plus cos squared x is always 1. It makes life easier. These cancel. This becomes a 1. Less the half equals a half. Looks a lot harder than it is. 13. People try and do this. That should not be even a thought in your head. You cannot do that. What should be the thought in your head when you see this? Use your formula sheet. This is your A, this is your B. So we're going to get sine 3 pi over 2, which is an answer. Cos of x plus cos of 3 pi over 2, which is an answer. Sine x equals negative cos x. And I always put these in brackets, so I realize that I'm getting answers, and then they're being multiplied by each other. Okay? Sine of 3 pi over 2. The coordinate at 3 pi over 2 is 0 and negative 1. What's sign there? Negative 1, because it's the y. Negative 1, cos x, nothing can happen to it. Cos of 3 pi over 2 is 0. Super easy if you remember that that formula does this. Super hard if you distribute. And by super hard, I mean impossible if you distribute into that bracket. You know what I'm saying? What about this one? 2 tan x divided by 1 minus tan squared x equals sine 2x over cos squared x minus sine squared x. So the tan x you could change. I'm going to just try and change this one. I know that I need to get, I'm going to change this one and this one. This one you could change to secant. There's so many different ways you could do this question and still get the right answer. So just if you didn't think to go this route, doesn't mean you wouldn't get it correct. Okay? You could change the tan to sine over cos. You could change this to swap out the tan for 1 minus secant squared, and then they would cancel. You could do stuff like that. It would be absolutely fine. I'm just going to swap this out. So I'm going to go 2 tan x over 1 minus sine squared x over cos squared x. I'm only doing this because I want to get a sine squared x and cos squared x on the bottom. Equals 2 sine x cos x, because that's what sine 2x is, over cos squared x minus sine squared x. I'm going to make common denominator. I'm going to get cos squared x over cos squared x. So I get 2 tan x, which we may need to change in a second, over cos squared x minus sine squared x over cos squared x. I have a crazy fraction in my denominator, so should I ever write it like this? Should write it how? Sideways. Now I'm going to need that cos to go away, that cos squared to go away, correct? In some way. So I'm going to change the tan to 2 sine x over cos x, which is a full fraction, divided by cos squared x minus sine squared x over cos squared x equals 2 sine x cos x. If this was a multiple choice question, if I had like left side in my question and then the right hand side answers in A, B, C, or D, would I have to prove it properly to do that? Could I verify by picking like pi over 3 or pi over 6 or 30s and 60s? Don't pick 45s. You could pick a 30 and 60 and see which one matches, right? You could do it that way. What they'll do often is they'll make it hard for you to plug it in your calculator. So they'll use like secants or cosecant squareds or stuff like that. So at least if you're going to do it that way, it's a 45 sometimes get you like the ones and stuff like that, which is they'll get you an answer that turns out that really isn't the best. Plus 30s and 60s are often easier. And just because it works for one doesn't mean it works for all of them, right? So I always pick 30s and 60s is what I try. You could even just type them into y1 and y2 and see which one gets you the same graph. You could check it that way, or you could verify it properly. Proof is the only way that it's a guarantee that it works, though, right? Verification only proves for one thing it works. Graphs only prove for that part of the graph it works. So if you want it to be a perfect proof, you'd actually have to physically prove it. Okay. So we flip. So we get 2 sine x over cos x times cos squared x over cos squared x minus sine squared x. Remember, you have to, no matter how lazy you are, write both sides every single time. If you're like, nah, no, you do. It's not proof if you don't, okay? This is correct. 2 sine x cos x. And you have to write the x's. You can't just write 2 sin cos. I don't even know what those are. That would be bad. So that one's right. Last page. This one you guys did a lot on tests and such. I'm just bringing it back because you did it a lot on tests and such and still are getting it wrong. So I'm showing it to you for like the 3rd time. Yeah. So cotan squared is cos, we could do it that way, or cotan squared and cosecant are besties. So I'm going to substitute. So cosecant squared is 1 plus cotan. So I'm going to go cotan squared theta minus, and what is it? 1 plus cotan. You have to remember to put it in brackets because it's two terms, right? So the subtraction sign has to go through. So you're going to get cotan squared theta minus 1 minus cotan squared theta. So these cancel and your answer is -1. Secant and tan are friends as well. Secant squared is 1 plus tan squared. 1 plus tan squared is what I'm going to fill in for secant. Minus tan squared. Tan squareds cancel. I'm left with 1. This is sine theta minus sine theta cos theta divided by 1 over cos theta, right? And these can flip, so you get sine theta minus sine theta cos theta times cos theta over 1. And then sine theta minus sine theta, bless you, which is 0. This one you can take a 1 over 7 out, and you're left with cos squared theta plus sine squared, and what's that? Some of you were trying to write the answers in the boxes. There's negative answers and fractions. You can't write them in the boxes. So you have to write the numerical values of the expressions. So in ascending order. So we start off with -1, which is actually 1. Then we go to 0, which is 3. Bless you. Then we go to 1/7, which is 4. We go to 1, which is 2. Cos 195. Is that on your unit circle? Is its friends on your unit circle? What friends? Which ones did I pick? Yeah. So cos 150 plus 45, which is cos 150 in brackets, cos 45 in brackets minus sine 150 sine 45. Then we go to a unit circle and pull our values off. Cos of 150 is negative root 3 over 2. Cos 45 is root 2 over 2. Sine 150 is a half. Sine 45 is root 2 over 2. So you're going to get negative root 6 over 2, because you multiply coefficient times coefficient, radicand times radicand instead of the radical. And then minus root 2 over, that's over 4. I always do this. Don't be me. 2 times 2 is 4. I always do common denominator by accident. So it's going to be -6 minus root 2 over 4. Now we walk away and hope we didn't screw up. You can check it. Type -6, negative root 6, even though I dropped it off. Negative root 6 minus root 2, and then divided by 4. So negative root 6 minus root 2 divided by 4. I get that. What was the original? Cos 195 degrees. So what do I need to be in? Degree. So I already am. Cos 195. Same decimal, right? If I ask you for cos 195 to the nearest hundredth, you could just type it in. They aren't going to. They're going to ask for exact values, make you do all the work. Okay? Tan 75. I will be finishing these two, so if there is a bell, I'm going to keep going. Tan 75 is what times what plus what? Tan 75 is what? This is where everyone goes downhill. This one people often do not get right, except for if they memorized it, which I know that that's what you're doing, just so you know. Yes. Tan 30 plus 45. Tan of 30, tan of 30 is sine divided by cos, so it's a half divided by root 3 over 2, which is a half times 2 over root 3, which is 1 over root 3, and then you rationalize it. So it's root 3 over 3. Yes, I know that's ridiculous, but it is. The formula for tan is tan 30 plus tan 45 over 1 minus tan 30 tan 45. Like I said, make sure you can do this. If you know you can't do this, you should be copying it down again. You shouldn't be on your phones because that's not helpful. And I'm not doing this for my benefit. Okay. Tan of 30 is root 3 over 3 plus 1 divided by 1 minus root 3 over 3 times 1. So you're going to get root 3 over 3 plus 3 over 3 because you need a common denominator divided by 3 over 3 minus root 3 over 3. Then you get 3 plus root 3 over 3 times 3 over 3 minus root 3. I'm flipping it. 3's cancel. And you think you're done, but you're not because there's still a radical in the denominator. So you have to multiply by the conjugate, which is 3 plus root 3, which is going to get you 9 plus 6 root 3 plus 3 all over 9 minus 3. 12 plus 6 root 3 over 6 takes a 6 out. So it's 2 plus root 3. The last one, we have given that cos theta equals negative 4 over 5, and it's between pi and 3 pi over 2, and sine b equals 2 over 3 pi over 2 between pi. Find the exact value of sine theta minus b. What is this asking you to do? No, it's not. No, what's the very first step you should do here? Draw it. So we do triangle theta, which is cook extra rice. So it's between pi over 2 and 3 pi over 2. If they give you a specific area, they're asking you to draw it and make a triangle every single time. You need to remember that. So it's pi over 2 and 3 pi over 2. So it's here. We're going to get negative 4 and 5. And I'm going to put a negative here because I know I need to have my y be negative. If you don't draw it, you're probably not going to make your y negative and get it wrong. Are they going to have the answer to your y positive? Absolutely. So you need to draw it. And we do Pythagorean Theorem. So we get y squared equals 5 squared minus negative 4 squared, which is y squared equals 25 minus 16. Y squared equals 9. Y equals plus or minus 3. You have to take the square root with plus or minus sign. It's going to be negative 3. This is triangle theta. Then we draw our other triangle, which is B. It's between pi over 2 and pi. It's here. Sign your resume. So it's going to be 3, 2, and this is going to be negative. But if you don't draw it, you won't know it's negative. Pythagorean Theorem, x squared equals 3 squared minus 2 squared. X squared equals 9 minus 4. X equals squared equals 5. Square root plus or minus. So x equals negative root 5. And this is triangle B. So anything from B comes off that triangle. Anything from theta comes off the first triangle. Use your theorem. So sine theta cos B minus cos theta sine B. This is a value. This is a value. This is a value. This is a value. Sine of theta is y over r. So here's theta, this triangle. It's negative 3 over 5. Cos of B. Go to B. Cos is extra rice. So negative root 5 over 3. Minus cos of theta, they gave us negative 4 over 5. Sine of B, they gave us 2 over 3. Most of you will fill in cos of theta, sine of b, and leave the other two blank and go, I have no idea how to get them. You have to draw the triangles to get these two. You'll fill these in because they're off the question, and then you'll leave these two blank, and that's not helpful on a multiple choice numeric response test because you're not getting it right. You're stuck, okay? You need to remember to draw the two triangles. So you're going to get 3 root 5 over 15 plus 8 over 15. So it's going to be 3 root 5 plus 8 over 15. Yep. Is there any way you can check this in your calculator? No. Is there any way you can match a multiple choice answer to this? No. You need to know how to do it or not. That's it. So if you forget that you have to draw two triangles, then find the third side. You're never getting this question. No amount of calculator magic is going to get you this answer. Okay? This question up here, so tan 75 we could have checked with our calculator, right? It's a numeric response. You're done again. What about this one? Could we have plugged in stuff for theta? Yes. So you have to remember there are ways you can check with your calculator, but there are some that no matter how much calculator battery you have, you are not getting that.